for NCGs, I wanted to talk a little bit about the challenges that the industry faces. In the case of, let's take a new greenfield industry like OSAT that we're doing. We'll take interns, we'll take NCGs because it's very niche, right? There aren't that many. But in the case of chip design, the large GCCs, they need laterals more than they need the NCGs, and they count on the design services ecosystem to train them after college and have these finishing school concepts. Foundry and manufacturing is a little bit different. The GCCs, like we're talking about, AMD, NVIDIA, Qualcomm, the product companies like Broadcom, etc., they pay very good packages for 3+ years laterals, but really getting that 0 to 3 is the biggest challenge in this industry, in my humble opinion. It's always a relationship that then comes in. Will you take a fresher? Will you take 1 year? Will you give us a buffer resource for free? Will you allow us to take out bad ones and put in good ones? The big companies don't want to deal with it, so they're giving it to the design services company, which in itself is a huge market because we're producing about 5 lakh engineers a year, of which only 5,000 are employable. So the opportunity to make them employable, not just educated, but employable, is also a massive task. Soft skills, interview challenges, how do you dress, how do you approach an interview, how do you get to complex problems, lateral thinking, design thinking. So the point I'm trying to make is on the manufacturing side, it's starting to emerge, and we can't get enough talent. And if they're skilled, if they're not going to computer science, which is a big challenge, they're staying in semiconductors, and then not only are they aware of a semiconductor, but they've gone through the coursework and know the fundamentals, then the task is to get them onto packaging. So we have our work cut out for us because we are so far away from what the knowledge is of these. So awareness, roadshows, hackathons, webinars, seminars, podcasts like this, spreading the word. What is a semiconductor? What is the future jobs? Is going to be first critical before getting into where we want to be on the packaging.
Got it. Now coming to the second part of the question, Sharat. So as in you see that there is so what happens is, especially the services firm prepare the talent for the GCCs to kind of poach it from, and then that has been the norm with most of the services companies that you see. So they create a post college this thing. So I wanted to understand. So if instead of getting them on payroll and then training them for 6 months and writing off their salary and training as a cost, is there a way that you think you can better equip these freshers, like what we were talking about, center of excellences, 1 year internship, and then how do you think, what is your perspective on what would you, if I give you a magic wand, what would you want?
We need to bridge that 0 to 3 gaps. That 3 needs to come down to 1 instead of 3 years, because that gap is still large, and that it's an ocean for these freshers, and they're lost. They'll take anything. Now, to bring that 3 down to 1, they have to be industry ready and hit the ground running. So you need to go and double click on the fundamentals on the specific protocols. And you need to start zeroing in and getting serious on where in the design flow or where in manufacturing you want to be. It's not enough to say, I want to be in chip design. We need to get to that next level and say, I want to be a chip designer in digital verification doing PCI Express Gen 3. You understand?
Mm-hmm.
You have a high likelihood of getting picked up by a GCC directly without going through a training school.
Got it.
Now, the training institutes are also partnering more and more with the GCCs to put custom-built curriculum and custom-built programs together, whether they're short-term or mid-term. Those are highly effective. Basically, the GCC will give a spec to a college or a spec to a design services company, and you would train the trainers to then be able to deliver product company X's specific requirements. That works. That bridges the 0 to 3 gap a little bit. Then on the so the 0 to 3 gaps is probably the point I wanted to make. The second part of your question on the challenges was?
As in, how do you make this, reduce this 0 to 3 to less than 1 year, and then, how do you think academia and industry can collaborate in form of internships and COEs?
So now, again, front-end design, back-end design, front-end manufacturing, back-end manufacturing. The next logical step beyond theory would be hands-on approaches. So in front-end design and in back-end design, there's a whole vast field of emulation, pre-silicon validation, architectural analysis, software simulation, etc. Those require labs. So I think hands-on labs, in addition to the theory, are going to be important. On back-end manufacturing, actually doing tape-outs, MPWs. I'm not talking about doing a production chip. I'm saying get that student to tape out their own chip along with many, many other students on a single die. So that is something which would be very attractive to anyone who's hiring. I've done a tape out. I have done a complete test bench for a USB protocol. It's that example. On manufacturing, same thing. We're planning to set up COEs at Kaynes, where we're actually setting up small prototype lines. So in parallel to the theory, we want to do hands-on labs and actually take them onto the equipment and actually experience it with the equipment. Kaynes will absorb these ourselves, and they will be much industry ready than they would be without having those hands-on and theory only. So the combination of the COEs, labs, along with fun projects like hackathons, ideathons, etc., are all going to be needed. And industry appreciates the winners of those hackathons. They appreciate the fact that an industry within academia has brought 1,000 students filtered down to 10. That's a big deal for a large company, because then they've said that we've been able to get the needle in the haystack, the diamond out of that, where we're reaching. And I think another aspect is the tier ones are taking a leadership role. The IITs, we've expanded the number of IITs, we've expanded the number of triple ITs. They're taking leadership roles. They're welcome to host the tier 2 colleges and even the tier 3 colleges and even the government colleges. I see a lot more handshaking and a lot more cooperation, not only within the states, but even across the states. And I see that the leadership and the ministry is working very well with the top tier ones to expand it down to the tier 2s at the base of the pyramid.
Got it.
Because that's where those gems are, which are unable to be unearthed.
Got it.
And that's happening today. And they should bubble up. So that's how it'll all come together. And Sir gave such great examples of how NVIDIA is setting up COEs. I'm sure they'll be giving you little Jetson packages, little GPUs.
Yes.
Alpha Wave will probably be talking about 2.5D and 3D packaging. They're talking about cutting edge IP. In the universities, we start with base protocols, but they eventually mature into the advanced technologies. For example, in colleges, we do 8051. That's nothing but the foundation of x86 and RISC. We do SPI. That's nothing but basically the foundation for parallel computing. The I2C is nothing but a serial interface, which leads to USB. So the fundamentals then need to be built on into the actual industry required protocols. And if we can start getting expertise on IP protocols, they're here to stay. We need to get on the MIPI standards. We need to get on the industry standards, the industry bodies, the certification bodies, and that needs to come from the academia also, I think. These are a few areas where I think we can address.